This is the Red Hawk talk for computer science program at Montclair State University. My name is Dawei Li. I'm an assistant professor in the Department of Computer Science. Meanwhile, I'm also the graduate program coordinator for the MS in Computer Science program, which is our master's program. Okay. So here's the agenda of my talk today. I will talk about what is computer science, and then I will talk about the Bachelor of Science in Computer Science program and the combined BS and MS in Computer Science program in our department. And then at last, I will talk about the department itself. Okay. So let's get started. So what is computer science? Here is the definition from Wikipedia. So computer science involves the study of or the practice of computation, automation, and information. Since these concepts may be quite abstract to you, so I'd like to provide some explanations or descriptions about them. So first, computation, because nowadays computers and many other machines can actually compute much faster compared to human beings. Okay, so we want to use these machines to do the computation for us. Okay, so that our human beings can be relieved from this tedious process. Okay, and then the second thing is automation, because usually in the real world and also in various sciences and engineering aspects, engineering fields, if you want to solve a problem, that usually involves a lot of steps. Okay, so we want to program our machines or control our machines so that they can do this series of steps automatically, so that we don't even to monitor the process and do the control during runtime. Okay, so this is automation. So that the machines will just automatically follow the steps to complete the tasks for us. And then the third aspect is information. This means we want to convert the problems in various domains into the information that can be processed by the computers. Okay, so that they can help us to solve problems in various domains, in various sciences. Okay, so we have these three important aspects in computer science: computation, automation, and information. Basically, again, computation means that computers can help us to solve to do complex computation because they are much faster, and automation allows them to complete the various tasks for us. And then with the information, we can ask the computers to solve various problems in various domains. Okay, so this is computer science. And then another perspective you can use to understand the computer science is to understand the various fields of computer science. Okay, so computer science spans theoretical disciplines such as algorithms, theories of computation, and information theory. It also includes practical disciplines such as the design and the implementation of hardware and software. Okay, so that we can build these machines, these computers, and program these machines, computers to help us to solve various problems. Okay. Computer science is a very broad field, and it has many fields, subfields. Okay, so algorithms and data structures are central to computer science. The algorithm means a step-by-step direction about how the computers should follow to solve various problems. Okay, data structures consider how we organize data within the computer. Okay, so they are actually very fundamental in computer science. Then the theory of computation concerns abstract models of computation and general classes of problems that can be solved using them. So basically, we can decide actually what problems can be solved by these computers and what problems cannot be solved by the computers. Okay. Then the fields of cryptography and the computer security involves studying the means for secure communication for preventing security vulnerabilities. We want the computers to solve the problems in a secure way. Okay. Then, of course, we have many other fields. Computer graphics and computational geometry address the generation of images. Okay, we do want our computers to be able to process information from various domains. Okay, and then images and videos are a very important field. Okay, and then programming language theory considers approaches to the description of computational processes. And the database theory concerns the management of repositories of data. Okay. And then human-computer interaction field investigates the interfaces through which humans and the computers can interact. And then software engineering focuses on the design and principles behind developing software. Okay. Of course, we still have more fields. The areas such as operating systems, networks, and embedded systems investigate the principles and the design behind the complex systems. Okay, because sometimes our problems may be very complex. Because we need to have complex systems to solve these complex problems. Okay, yeah, the problem may get problem size may get very large. Okay, the data amount may get very large. So we need to have large systems and complex systems to be able to store the large amount of information and then solve the problem. Okay, so we need to consider the principles and design behind complex systems. And the field of computer architecture describes the construction of computer components and the computer operated equipment. Okay, these are concerns the construction of computers. Okay, we have general principles, rules that we should follow to build a more efficient computers. Then the fields of artificial intelligence and machine learning aim to synthesize goal-oriented processes such as problem solving, decision making, environmental adaptation, planning, and learning found in humans and animals. This basically means we want our computers to have the intelligence of human beings. Okay, because although computers can be efficient in solving some problems, but they are not that efficient in solving some other problems, which our humans are actually able to solve efficiently. Okay, so we want the computers to have the some intelligence of humans and animals, so that they can also solve other problems efficiently. Okay. Within the artificial intelligence field, computer vision field aims to understand and process image and video data, while natural language processing aims to understand and process textual and linguistic. These are computer vision and language processing are both subfields within the artificial intelligence field. Okay, of course, there are many more fields within computer science. Okay, so this is really a very broad discipline. Okay. Another perspective you can use to understand computer science is to understand the various applications of computer science. Okay, so the knowledge from computer science can help us to build robots, right? Okay, so robots can be basic robots, and we can also add artificial intelligence to these robots so that they can even think and behave like humans, right? We can also use the knowledge from computer science to build the self-driving cars or autonomous vehicles, right? Because these self-driving cars or autonomous vehicles is actually very similar to a computer, except that their main focus is on self-driving, okay, instead of this general purpose computation. So basically, on a self-driving car, you may have many sensors, right? These sensors can sense the environment, and then you have a control system, just like an operating system that uses the sensed data to make driving decisions. Okay, so really, yeah, these self-driving cars or autonomous vehicles are very similar to the computers. So of course, yeah, the computer science majors and computer scientists can help develop these self-driving cars and autonomous vehicles. Okay, this is actually a very exciting future, right? Because these self-driving cars can even fly in the future. And then for some more familiar applications, we have like various voice assistants like Amazon Alexa, Google Assistant, right? Apple Siri. Have you used any one of these? I can type yes in the chat if you have used them. Yes, great. So yeah, these are all used to use Apple Siri. So have you stopped using it? You switch to Samsung. Okay. Yeah, I mean, there are a lot of voice assistants nowadays, okay, from big companies, either Amazon, Google, Apple, or Samsung. Of course, there are still many others, but anyways, these are all important applications of computer science, okay? Of course, we have many other applications, like all the desktop applications you are using are developed by computer science majors or computer scientists. We also have Android apps, iOS apps, right? And we also have specialized applications like computer games. I believe this is what you are very familiar with, right? These computer games can, of course, run on various platforms, including specialized gaming consoles such as Xbox, right, PlayStation, or Nintendo Switch. I mean, all these devices, the gaming consoles, are built by computer science majors or computer scientists. And then the computer game applications themselves are also developed by the computer science majors, like software developers, software engineers, okay, UI developers, and so on, right? So these are all applications of computer science. Yeah, these are computer devices, okay, the desktop machines, laptops, the tablets, the smartphones, the smart home appliances, smart Internet of Things, right? They are all built by computer science majors, computer scientists. And then the operating system running on top of them are also designed, implemented, developed by computer science majors. Okay, so really, computer science is a very broad field. You may have heard of many other fields like information technology, data science, cybersecurity, software engineering, computer engineering, electrical and electronics engineering. Okay, in my opinion, they are all part of computer science, or at least they have a tremendous overlap with computer science. Okay, so really, computer science is everywhere. Okay. Also, the knowledge of computer science can be used to help with other sciences or domains. Okay, you can use computer science knowledge to solve problems in biology, So we develop a special domain called the bioinformatics. Of course, you can use computer science knowledge to solve our problems in social science, right? So you have computational social science, and then also you have computational linguistics, okay, cognitive science, okay, and the geographical information systems, okay. So really, yeah, computer science is everywhere, and it can be applied in various sciences and domains. So if you have chosen computer science, okay, kudos to you, because this is really a domain of significant importance, okay, and it is the future. If you choose this domain, you choose this as your career, then you will be very likely to be successful, okay, because the job market needs many computer science majors, okay. Again, various sciences and domains require some computer science knowledge, okay. So yeah, if you have choosing this as your major, that is a good choice. So any questions? You can type your questions in the chat. Not yet. Good. So next, I just talk about the programs in our department. Okay, so we have this Bachelor of Science in Computer Science program. So here is an overview of this program. We require a minimum of 120 credits. Within these 120 credits, there are 32 general education credits. You need to take some general education courses like history, philosophy, languages, and so on. Then you have 3 to 9 credits in world languages and the requirements. After that, you have 74 credits in major requirements. So as you can see, you need to take a lot of major courses. Yeah, computer science is an exciting field, but before you can work in this field, you do need to learn a lot of knowledge, right? So you need to take a lot of courses, okay? So we have 74 credits in major requirements. After that, you need to take an additional 5 to 11 free elective credits. Usually our students will use these free elective credits on major courses, okay, because really you need to learn a lot about this major, so you can continue to take major courses, okay. This information is on our university website. You can always go to check that, okay. So here I want to provide more details regarding these major requirements. Again, you need to finish 74 credits within these requirements. So we have several categories within these major requirements. You need to take some natural courses. So you can choose biology or chemistry or physics. Okay, you need to take 8 credits within either one of these tracks, okay? So typically you need to take 2 biology courses, 2 chemistry courses, or 2 physical courses, okay? After that, you need to take some math courses, okay? It's 18 credits. And then you need to take the computer science core courses. After that, you take some advanced courses. So the advanced courses include the specified courses and also electives, okay? So we do give you some flexibility. So if you are more interested in some courses, you can choose to take those courses, okay? So in the first 2 years, students in our major usually take these courses, CSIT 104, Python programming, CSIT 111 and Y112. This is Java programming. And then data structures, computer systems, systems programming, discrete math, and then calculus 1 and 2. And then after that, you will take some advanced computer science course. So we have foundations of programming languages, computer networks, operating systems, databases, okay, computer science theory, computer security, and many more. Okay. So yeah, this is computer science, the Bachelor of Science in Computer Science program. Okay. Any questions regarding our program? Okay, let's continue. So next, I'd like to talk about our combined BS and MS in Computer Science program. So before I talk about this combined program, of course, I need to talk about our MS in Computer Science program first. So our MS in Computer Science program requires 10 courses or 30 credits. Okay. We do have some bridge courses for non-CS majors, but if you already have the Bachelor of Science in Computer Science program, then of course you don't need to take these bridge courses. Okay, this is not your concern. Okay, so if you are in BS in Computer Science, then you only need to take another 30 credits to get to this MS in Computer Science degree. Okay. Among these 10 courses, we have 3 required core courses, and then 5 elective courses, and then 2 courses for the capstone experience. Okay. So again, the MS in Computer Science program requires 30 credits. So what's this combined BS and MS in Computer Science program? So basically, if you do these 2 programs separately, then you need to finish 150 credits, right? 120 credits for BS in Computer Science, and then 30 credits for MS in Computer Science. However, if you choose to do this combined program, then you can finish both degrees with just 144 credits. Okay, why is that? Because 6 of the graduate level courses will also count towards your undergraduate program. Okay, so that means yeah, these 6 credits are double counted. Okay, towards both your undergraduate program and your graduate program. So if you do this combined program, then you only need to finish 144 credits instead of 150 credits. Okay. So in this way, you can finish these 2 degrees within 5 years. If you don't do this combined program, if you do these 2 programs separately, then generally you need 5.5 years. Okay. But if you do this combined program, you can finish these 2 degrees within 5 years. That's typically the case. Of course, that depends on how many courses you take, right? But generally, yeah, if you do this combined program, you only need 5 years. Okay. Any questions regarding this combined program? Great. Feel free to ask any questions. Okay. So let's continue the last item on my agenda. Can we combine computer science information technology? Good question. Yes, you can. Okay, so we not only have this combined BS and MS in computer science program, we also have a combined BS in computer science and MS in IT. We also have a combined BS in IT and MS in computer science. We also have a combined BS in IT and MS in IT. Okay, so you can go to our department website to find all these offerings. Okay. We also have combined BS in computer science and MS in data science. We also have a combined BS in computer science and MS in cybersecurity. Okay, so we have many options. Great. So the last item is some information about the department. Okay. So we have about 900 undergraduate students and about 160 graduate students. Our typical class size is 25. So that means you can receive enough attention from your professors. We have more than 22 full-time faculty members, okay, all with a PhD degree in a CS-related field. Okay. We have many degree programs. At the undergraduate level, we have a BS in computer science, BS in IT, BS in data science. We are also developing a BS in cybersecurity. Okay. At the graduate level, we have MS in computer science, MS in IT, MS in cybersecurity, and MS in data science. Okay, so we also have various combined programs. Okay, basically you can pick any undergraduate program and any graduate program and combine them. Okay. We also have MS in computational linguistics program. This one is jointly run by our department and the Department of Linguistics. Okay. Okay, so that's